Okay, good afternoon, children. Today we are discussing about the carbohydrates. Today we discuss the carbohydrates. There is okay. Fastly moving that one. You can finish the what are the important one. So the page number 129, classification of the carbohydrates. Yesterday we discussed that one. Monosaccharides, oligosaccharides, and polysaccharides. The classification, after the classification, general reactions of the carbohydrates. That is the main oxidation method. That is oxidation. In that oxidation, we are to using of the toluenes and failing solutions. The reduction process will take place, and oxidation of the bromine water, and oxidation with periodic acid. And the second is the oxygen derivative, formation of the oxygen. And the next is you are having of the there are three are important general reactions of the carbohydrates. Okay. So for the 10 marks question, we'll ask first you have to write the only monosaccharides. That means particularly you can identify the monosaccharides with help of the Tollens and Fehling's reagent, but you can't identify the in between the monosaccharide, that means glucose and fructose. Only monosaccharide will be identified with the help of the Tollens and Fehling reagent. Tollens reagent, you can get in the silver mirror on the test tube. Fehling reagent, you can get the red ring will be present on the test tube. That will be, you can easily identify with the help of that one, identification of the carbohydrates. Next, the bromine water, we can get rid of the particularly aldose built by aldonic acid form. Periodic acid, how many number of moles of the periodic acid is used in that one? How many number of moles of formaldehyde and formic acid is obtained from that reaction? You can use that one. Next, the formation of the oxygen, that is the phenyl hydrogen. When the glucose or fructose can be reacted with the phenyl hydrogen, formation of the oxygen is formed. Both can be, you can using of the oxygen formation will be takes place. Okay, these are the important areas which are present in the general methods. Now coming to the one more method is there. There is a Molish test also. Sometimes it is lost, but important is the conversions. Important conversions are in the page number you are having of the 135 and 134. Page number 135 and 34 you are having the conversion. Lengthening of the carbon chain, that is Killian-Fischer synthesis is there, very important. That means you can aldo pentose to aldo exose. The conversion will be takes place. Aldo pentose to aldo exose formation will be takes place. This is called as the lengthening of the carbon chain. There is a Killian-Fischer. Now shortening of the carbon chain, that is also there. You have from the glucose to pentose. That means exose to pentose. That will be formation exose to pentose. That is shortening of the carbon chain. That is also present in the 135. And the conversion of aldose into epimers. Interconversion, aldose to fructose. That means glucose to fructose and fructose to glucose. That will be interconversion will be there. This is a 4 reaction out of 4 reaction. Any one compulsory in that examination point of view. Either it is 5 marks or 10 marks bit, it will be very important of that one. Okay, that interconversion means lengthening of the carbon chain, shortening of the carbon chain, formation of the epimers. Okay, epimerization will be takes place and conversion, interconversion, that will be glucose to fructose or fructose to glucose. That is the interconversion will be takes place. Okay, that you have to mention in that case, you have to practice it. We are getting of the 10 marks in that. Next is the monosaccharides. Where the monosaccharide, how the monosaccharides are occurrence, what are the manufacture, how the sucrose, that is the formation, And what is the open chain structure of the glucose? That is also very important. Open chain structure of the glucose, page number 138. That will be very important. For that, we have to write all the equations which are having of almost 6 to 7 points are there. How the structure of monosaccharide D-glucose will be. We are using of the open chain structure identification will be takes place. Okay, page number 138 is very important. Next, go to that one. How many stereoisomers are possible? Stereoisomers already, I know that already we see that this is the glucose. Here, 4 asymmetric carbon atoms are there. 4 asymmetric carbon atoms. 1, 2, 3, 4. The formula is to form n isomers will be formed. So means 4 means it is nothing but 16 isomers are possible for the glucose. So stereoisomers are 16 isomers will be possible due to the 4 asymmetric carbons are present. Due to that reason, you are getting of the 40. There is a 16 isomers will be possible. That will be using of that one. And next is the limitations of the open chain compounds. There is the limitations which are present in that. You are having the page number 141. You are having of the limitations. Next is a cyclic structure. It is also asking for the cyclic structure also. Page number 141, 142. Okay. Next, conformation of the D-glucose. So regarding of the glucose, these are the important. Next, fructose. Page number 146. Structure of the fructose. That is the open chain formula. This is only for the 5 marks question. They are asking of the structure of the fructose. Open chain formula. We are using of that one 146.
Sir, only these topics are important for examination point of view.
Next, 148 page number, cyclic structure of the fructose. This is important. You are asking the cyclic structure of the fructose. So you're writing of the formula of the fructose, then the cyclic nature, how it is represented, that you have to practice it. Okay. This is about this chapter. Next, carbohydrates 2. There is a disaccharides. How the disaccharides will be obtained. That is main important sucrose. When the sucrose is hydrolyzed, you are getting of the glucose and fructose. That will be then we are having of the main some important reactions which are on the sucrose. We are having of the not that much of important, mainly important of the polysaccharides, uses of the cellulose and its derivatives. The cellulose, that is a Page number 157. Cellulose molecule structure is given. Uses are given. Uses are asking every time. Uses of cellulose and its derivatives. And they asking the starch molecule. Starch molecule. What is the starch molecule? We are having of the symmetry of that this segment will be that to represent the structure. That is enough for in the second chapter. Only few important in the polysaccharide and oligosaccharides. What is that polysaccharide, particularly cellulose structure? Okay, cellulose structure and its uses and its derivatives. What are the derivatives? Okay, this is about the organic part. We are coming to the physical chemistry. We are having of the three chapters are there. Very important three chapters in that chemical kinetics, thermodynamics, and electrochemistry. Totally theory is there. Completely theory, but in that chemical kinetics, little bit of the equations are there. That means mathematical equations which are assuming. So you are derive the first order reaction, second order reaction, third order reaction. That is a derivation part will be there in this chemical kinetics. So if you are having the time permits means you can easily derive the first, second, third order reactions easily. But we have to practice it. Then only you will get the examination in the point of view, you can write it properly. So there is a systematic way there. So in that particularly the short questions are main is order of reaction, rate of reaction, page number 164 and 165. What is order of reaction? What is order of reaction? That means you can identify with help of the equation if the number of what are the components which is present in that one, and the reactants, how many reactants are participated, that you have to identify with the help of the reaction, then only you can find out the order. The order is the reaction is identical with the number of atoms or ions of the molecules whose concentration is determined in the reaction is called as order of reaction. Okay, so the order of reaction is depending on the yours equation. When it is having of when A is gives the products means it is a first order reaction means it is depending on the only one A gives the product. So order of reaction is the rate is nothing but here we are using of the rate is there is a constant term, the concentration of this one number of molecules are one. It is a first order reaction. If suppose we are taking of the 2A gives the product, you can say 2A or sometimes you can say A plus B also. Doesn't meaning of that one. The rate is here rate is nothing but the concentration term that is A2. This is a second order reaction. Okay, like that you can identify the help of the order of the reactions here. So what is the order? What is the molecularity? What is the rate of the reaction? That is the short questions we are asking in the this particular. Okay, you can easily use of that particularly page number 165 and also molecularity of the reaction page number 166 is there. Next, immediately arriving the reaction of the first order, determination of the first order reaction. In this your book, it is a lengthy process. Is there not lengthy, but it is having of the so many theories are there. No use of that theory, just equations. What are the we are giving of A is give the product. So rate of reaction is nothing but minus dC by dt is equal Kc. Simply we can write other dC by dt is equal to Kc. Then you are writing of this one whether the formula of the differentiation of the equations, that means it is particularly integral calculus will be having of the idea. Only mathematics students can easily do that one particularly, but you can practice one, any one of group you also can use, you can derive the equation first order reaction. The first order reaction is nothing but K is equal to 0.303 by T log A by A minus X. This is called as a first order rate equation. 2.303 by T log A by A minus A is the initial reactant. X is the final product that will be getting off that one. From that you can using of the first order reaction. Okay. And first order reaction, what are the examples? You have to write the examples of first order reaction. Nitrogen pentoxide, when you are dissociated formation of nitrogen dioxide and of oxygen molecule. These are very important. And hydrolysis of ester also. When ester is hydrolyzed, you are getting of the acetic acid and ethyl alcohol. That will also comes under the first order reaction examples. This hydrolysis of esters you can do in your practicals in the 5th or 6th sem. That will be there, hydrolysis of ester. So you are getting of acetic acid and alcohol will be formed. Next, same thing, second order reaction also. You can derive the second order reaction. That means A plus B, two concentrations in the reactants give the products. So that it is a second order reaction. In the second order reaction, derivation part will be there. So that is nothing but K is equal to 2.303 by T into A minus B log B into A minus X by A into B minus X. That will be derivation part. That will be getting of that one. That is the second order reaction. So on that second order reaction, examples are given. Some example play important is, that means both the reactant concentrations is under determination of the rate constant. That's why E ester plus base alkali sodium hydroxide formation of acid and alcohol. That is a second order reaction. Similarly, third order rate reaction, you can derive the third order. K is equal to 1 by 2T into 1 by A minus X square minus 1 by A square. That is the third order rate reaction that you have to derive. Okay. So every one is the same formula, but getting of the integration clause, the integration part, that from that you can derive the rate order reaction. Just go through that one. If it is having of the knowledge, you can practice it. Okay. Otherwise, only the small questions are, what is the order, what is the molecularity, what is the rate determinant step. Okay. So that you have to use in the examples. And also sometimes they ask, what are the examples of the first order reaction? Give the equations. What are the second order reaction example? What is the third order reaction example? Better to remember 3. And the next is a very, very important question is 174 page number. Determination of order of reaction. We are having of the 4 methods are there. Integration method, off-time method, and also one-Toff's differential method, Oswald isolation method. These 4 methods are given. Sometimes they ask the 4 methods also. It may be a 20 marks question. Okay. Determination of order of reaction, page number 174. That much of important is given for this particularly. So you have to please go through this particular page number 174. What is integration method? What is off-time method? What is one-Toff differential method? What is Oswald isolation method? That you have to use. That is a totally theoretical matter as well as the equation is there. That you have to remember. That means you have to practice it. Okay. In that, no need of the doing of the problems or whatever it may. Just only what is the method you have to write. Next question in this chapter is no more. These are only okay. So 3 important derivatives and determination of order of reaction methods. Very important. That means 4 questions is the chance of 4 questions. 4 essay type questions are present in this chapter. There is a chance of getting of 1 compulsory. Mainly important determination of order of reaction, or derive the first order reaction, or derive the second order reaction, or derive the third order reaction. These are the questions which are present coming from the chemical kinetics. Okay. And the short question is, what is order of reaction? What is molecularity of the reaction? What is rate of reaction? These are the short questions which are appears in the examination. Maybe sometimes examples of the first order, second order, third order reaction. Give the few examples of the first order, second order, third order reaction. That you have to remember. You can go to the next thermodynamics. It is also very important. If anybody MPC student that is already you are having of the physics, it is the same chapter is given thermodynamics. Here also it is repeated. The physics students is easy for this particular thermodynamics. Anyhow, you are studying in the physics. That is only the same here also. the keeping of this particular order of reaction, what is the system, what is the work, what is the energy, and what is the isothermal reaction, what is adiabatic system. These are all important ones. That means lastly, Joule-Thomson effect experiment is given. Okay, Joule-Thomson experiment is compulsory for 5 marks bit in the chapter. So I will use of the particularly I will give the some important of this way. The page number 195, 195. Application of the first law of gas, first law of thermodynamics. That you see that one, you can derive the Cp minus Cv is equal R. Cp minus Cv everywhere, every time. Derive the Cp minus Cv is equal R. Universal gas constant. That will be question will appear in the examination. This is a uses the base applications of the first law of thermodynamics that you have to derive with the help of the simple phenomenon will be given. Okay, that is work done means Q is equal delta E plus P delta V. From that you can derivation will be takes place. That is a process will be derived. That is the 196 page number is there. Next is the adiabatic process.
Sir, we only have to derive Cp minus Cv, right? That's
That's
it.
it. That's it. Sometimes it
And
may be
that
five.
process and that
Some,
process is given in 196, right? Page number.
yes, yes,
Constant pressure and constant temperature, I guess.
yes, yes.
Volume, constant volume and constant pressure.
Now page number 206, Joule-Thomson experiment. How the gases, the temperature will be decreases. We are showing of this Joule-Thomson effect. The experiment measured. Mainly important of this is figure and what are the you are using of the piston by mid piston or the constant pressure you are getting of that one. That we have to derive in this particular 206 page. Joule-Thomson experiment 5 marks bit. From this it is over. Next is the electrochemistry. Electrochemistry again the short that means Faraday's laws are there. Faraday law and also totally these 3 chapters are nothing but theoretical theory is there. So complete theory is there. That's why you give the less important than the remaining other topics. But I say that black 1, black 2, black 3 is very, very important. Very good questions are there. Direct questions are there. No need to worry about just you have to practice. Little bit practice is enough. But here in this 4th chapter, main 4th block, physical chemistry, particularly chemical kinetics, thermodynamics, electrochemistry. These are 3 are very big chapters. Very, very big chapters. We are having the so much of idea will be there. What is the electrochemistry? What is the cell reaction? What is the Faraday's law? Everything you have to know that one. The fundamentals, without having the fundamentals, you can't study this particular chapters. Even the thermodynamics. Thermodynamics, what is the work? What is energy? What is isotherms? What is adiabatic process? Okay, this you know the terminology first of all. Then only you can enter into what is the first law of thermodynamics, second law of thermodynamics, zero order of the thermodynamics. Without having of any knowledge, I can't start directly. That is the problem of here given the chapter. I don't know why it is given without introducing of the important what are the fundamentals that is not given here. Directly they started that one. Even the chemical kinetics, if you see the chemical kinetics, the first you have to do what is the rate of the reaction? What is the rate? What is the order? What is the molecularity? If you are having of the idea, then only you can derive the first order rate reaction. From that only, that means how many number of molecules are involved in the rate chemical equation. In the rate, that means your rate determines how many number of moles of the reactants. What are the concentration of the reactants you are involving in that? What is the product is obtained? Product is immaterial, of course. Here only the concentration of the reactants are important. If you know that one, then only you can derive the first order reaction. Similar manner, second order. Why? Because second order means number of atom reactants are 2. Their number of reactants are only 1. The concentration is 1 means it is the first order, 2 means it is second order. The remaining, if it is 3 means third order. That is only the difference will be there. But sometimes if you are using of the hydrolysis of ester, the hydrolysis of ester is a pseudo first order reaction. Why I am calling this pseudo first order reaction? Here two reactants are there. Ester is there, water is there. The water concentration you are not taking consideration in the hydrolysis of ester. So that only the concentration, that is the order is depending on the concentration of ester only. That's why it is called as a first order reaction. But one more reactant is there. That's why it is called as a pseudo first order reaction. That is the fundamentals as given. I can't explain it in 1 hour all these things. That's why, for examination point of view, only I'm taking up the pages. You have to take the whatever the first order reaction, just derivation part, second order reaction, derivation part, third order reaction, derivation part. And first order reaction, what are the examples? Second order reaction, what are the example? Third order reaction, what are the examples? That's it. That's enough. Apart from that one, determination of order of reaction, some methods are there that you have to remember. The 4 methods are given. Okay, so that chapter is enough for that particularly. Coming to the thermodynamics again you are having of the little bit confusion will be there. Theory will be there. What is, we don't know the without having of the work done by the system, adiabatic system or isothermal system. How is the temperature is constant? Where you are keeping of the pressure constant? Where you are keeping the volume constant? Cp minus Cv, how can you get one? That will be, you have to little bit of confusion, but better to, if you are having of the book is there, you have to take the notes from that derivation part is clearly given. Derivation up to derivation part you can practice this. You will get some marks here. Next, coming to the electrochemistry, this also electrochemistry is a very important of that one, but the fundamentals are what is the electrolytic conductor is there, what is a good conductor, what is a buoyant conductor, how it is given as, what is the S law of heat of summation, what is the Faraday's laws. These are all laws. If you know them, then only you can go to the electrochemistry. This that much, whatever the basic knowledge you don't have that one, that means you have to learn that one basic knowledge. Then only you can directly go to the electrochemistry. The phenomenon of that particularly you are using of the Faraday's laws. In that Faraday's laws, where the cathode anode, how the electrons are distributed, how the that is a means you can prepare the cell constant and what is the EMF of that one that you have to derive this one particularly. So according to your examination point of view, I can suggest only in this chapter suggest this one. Everyone is complicated everywhere is that. At least you go through that one page number 226. Theories of electrical conductance. Theories of electrical conductance. That is given. So Arrhenius theory is given. In that Arrhenius theory is I, want of factor, I is equal want of factor is I is equal to observed colligative property by the calculated conjugate property. That is given by that we are derive the want of factors from that equation. And the next is very important in this chapter is 228 Oswald dilution law. In the chapter, the important is Oswald dilution law that you have to take into consideration.
Sir, for how many marks will they be coming?
It is a 10 marks bit. So it is nothing but K is equal to C alpha square by 1 minus alpha. This is Oswald dilution law.
And for Arrhenius theory?
From that Arrhenius theory only.
No, how many marks, like how many
All are
weight?
10 marks bits only. These are all our 10 marks questions. Okay. This is Oswald dilution law. From that we are having of the how the dilution law is applicable for the strong electrolytes or weak electrolytes. How it is behavior that we have to mention in that one. Next is one more is the Debye-Hackel theory. Debye-Ackel theory, total completely theory is there. That also in the examination they are asking the question. So page number 230 that is given as Debye-Ackel theory, that is also there. So I hope that here we are having of the total 3 chapters are complete theoretical, completely theoretical. Just only the thing is, if time permits, after the finishing of the 3 blocks, then come to this one. Why? Because derivation parts you have to learn. Derivative parts only. Suppose Debye-Ackel rule, you can't write. Why? Because strong electrolyte, weak electrolyte, how they are distributed in a electrolytic process. That particular that means that whatever the tempo that will you have to, that knowledge will be there, then only you can write the Debye-Ackel theory. Otherwise, you can't this one. The theory is a very laborious process. That means electrolytic conductances. When the cell is dipped in that one, when electrolysis is carried out, you are giving of the where the strong electrolyte goes, where the weak electrolyte goes. That will be the transport number. We are using of the by means of that one. We can derive the equation. That is a very lengthy process will be there. So better here in this 4th block, you may chance of writing of easy is the first chapter, the chemical kinetics. Derivation parts are there. Total derivative parts are there. You can practice it. Once you are getting of that particular derivative parts, easily getting of the full marks. Why? Because without having of any steps, you can't getting of the last equation. That is first order reaction. K is equal to 0.303 by T log A by A minus X. That will be derived with the help of the equation only. You can't get what is the A is the initial concentration. X is the final, that one we are getting of that one. That you have to derive. T is the half-life period of that particular equation. What is the T? Okay. T is the time taken by the reaction when proceed it. How much of the time will be proceed to getting of the products, that we have to derive that particular equation. And 2.303 at a constant, that will be a slope will be getting of the by means of the taking of the graph. First order reaction is the getting of the A, it will be passing through the origin, a straight line will be getting. That is the first order reaction. So like that you have to derive the equations. That is only easiest concept in this particularly chapters. Now these are the syllabus which are having of the 4 Sem. I hope you can understand easily by seeing of all the chapters. First block is very easy. Only the thing is that means we have to concentrated D block and F block elements and coordination. Coordination chemistry, we are having our 3 theories are there. Werner's theory, Sedgwick theory, crystal field theory. Sometimes valence bond theory also. But known as valence bond theory. Why? Because it is the lower classes valence bond theory. Mainly 3 are important in the coordination chemistry. And important here is isomerism. Coordination, that is a complex compound, isomerism, how the isomerism is taken place. Bond linkage, that means ligands, isomers, you are having of that one. Isomerism is also very important. And D and F block, very easy. That is a variable oxidation state, magnetic property, and also we are having of the color property, complex compounds. Next, we are having of the organic part. We are having of only 3 chapters are there. See, if you are concentrated on 3 chapters, nitro compounds means all nitroalkanes and nitrobenzenes preparation. Next, amines. Simple amines, primary amines, and aromatic amines, aniline preparation. And the preparation of diazonium chloride, aryl diazonium chloride or benzene diazonium chloride. How do you prepare that one? Simply, I already told that we are prepare the benzene diazonium chloride by the aniline only. When the aniline is treated with the sodium nitrate plus HCl at about the temperature is 0 to 5 degrees, we are getting of benzene diazonium chloride is formed. This is a standard equation. By that equation, you can get the so many number of byproducts. So in the examination, they may ask that how can you prepare benzene diazonium chloride from benzene? Won't get in your book. But the idea is benzene. How can you prepare the benzene diazonium chloride from the benzene? Means first you have to take the initial is the benzene. When benzene is treated with the nitration mixture. What is the nitration mixture? Concentrated sulfuric acid and concentrated nitric acid. That is treated with the benzene and also taking up the temperature 0 to 50 degrees or in between the 50 to 60 degrees. Means less than 60 degrees only. The nitration mixture will be treated with the benzene, formation of nitrobenzene. After the formation of the nitrobenzene, when your reduction takes place in presence of metal plus acid, you can take the metal zinc or tin, Zn plus SCl or Sn plus SCl, tin or SCl. That means reduced takes place, nitrobenzene is formed as aniline, NH2. Then the 9H2 we are treated with the nitric acid. That means sodium nitrate plus SCl, 0 to you are getting of benzene diazonium chloride. That you have to remember. Then this is only the practice only. You are getting over the practice purpose. Suppose the nitrobenzene is prepared. What are the chemical properties means? You can use either at 100 degrees Celsius, automatically beta-dinitrobenzene is formed. Simple case. In the acid media, in the neutral media, in the basic media, what are the compounds we have formation? That also you have to remember the preparations. That means the nitrogen compounds 1 and 2 is a very important to get the good marks. And the amines, you are taking the amines. How to prepare the amines means aniline is prepared. Only nitrobenzene is treated with that one. Reduction takes place. You are getting of aniline. Reverse order of the first reaction. That means that is nothing but aniline is prepared. In that, the important is distinguish with our separation of the aniline by the Innsberg reagent. Primary, secondary, tertiary amines are separated by means of Innsberg reagent. Benzene sulfonyl chloride, that is a reagent name is benzene sulfonyl chloride, C6H5SO2Cl, the formula. Why I am saying before in the 2 years before, yeah, these are the number of short bits. That means the multiple choice question they were asking the formulas. What is the reagent, Innsberg reagent, like that. You have to remember. By means of that one, you can getting of the separation will be takes place. When you use it in the ether, in presence of ether, some of the compounds will be absorbed by that one, some of will be disobserved. So that you can bifurcate it. So that you are getting up the slowly, one by one will be separated out. First, tertiary amine will be separated. Then again, the reducing of the temperature, secondary amine is separated. Lastly, you are getting of the primary amine. That is the Innsberg reagent will be taking place. That is a nitrogen compound, that is the amines. Okay. Next is the third block. We are having of the important chapters are only carbohydrates. Classification of the carbohydrates. Next, what is the monosaccharides? When the monosaccharides cyclic structure, how the general methods of preparation of the monosaccharides that will be there. That means because of the oxidation, when the failing then that is the tolerance reagent, what happened? Monosaccharides only getting of the color, remaining other does not react with the tolerance reagent and failing solution. In that monosaccharides, you can't identify can't differentiate that means glucose and fructose. Sometimes both will be reactive positive. So that's why here only the monosaccharides with the oligosyl polysaccharides we can differentiate with the help of the failing and tolerance reagent. Molish test also there. From that Molish test also you can identify with the help of monosaccharides also. Okay. Next is in that general reactions, ozone formation. Phenyl hydrazine is reacted with the glucose or fructose. Ozone is formed. That is a direct step. Next is we are having of the epimers is there. We can using of the epimers, how the epimers are formed. That means a identical, that is a mirror image structure will be formed. So general methods will be there. Next, how can you illustration of the structure of the glucose monosaccharide? There is a so many 7 reactions are there. By means of you can determine the structure will be. It is a nothing but the polyhydroxyaldehyde. Having of the 6 carbon atoms are there. In the 6 carbon atoms, 4 carbon atoms are asymmetric carbon atoms are there. Due to of the 4 asymmetric carbon atoms, you can get the 2 to the power of n. That means 2 to the power of 4. 16 isomers are possible for the glucose. 16 isomers are possible for the glucose. That is given by that one. Okay. So cyclic structure of monosaccharide. Next is the fructose. What is the fructose? What is the pyranose cyclic form? That will be carbohydrates. First chapter. Second chapter carbohydrate is oligosaccharides. Oligosaccharides, particularly the sucrose. When the sucrose is hydrolyzed, you are getting of the glucose and fructose. That's it. Then you are having of the what are the polysaccharides? Polysaccharide, when particularly cellulose. What is the structure of the cellulose? Why? Because it is a formula is 6,6H10O5 n times is there. Means number of molecule. When is this a cellulose or starch will be hydrolyzed, you are getting of more than 10 monosaccharide units. Sometimes it is given as 100, up to 100 monosaccharide units also possible for the cellulose structure. That much of cellulose will be there. That means the carbohydrates are very rich amount of the carbohydrate which is present in the polysaccharides. That is a cellulose. What are the uses of cellulose? Where it is used? Next is the starch. What is the structure of the starch? That's it in the third block. Next is the fourth block. That's why I'm very much concentrated on 3 blocks only for getting of the 80 marks. If you are thorough with the 3 blocks, you will get the 80 marks, no problem. But you are completely thorough that one. If you have any doubt in that one, please go to the fourth block. There is a physical chemistry. In that also, we can prefer the first chapter, chemical kinetics. What is the rate of the reaction? What is the order of the reaction? What is the molecularity of the reaction? Okay. And also, what is the first order reaction? What is the second order reaction? What is the third order reaction? And determination of order of reaction methods. That's it. We are having of the chapter. That's it only. Okay. So, anyhow, I can just brushing up that all the chapters. If you are having of the doubts, now today 3 members are there. Only 3 members. If you are having of any doubts regarding of this one, our examination point of view, there's a having of the questionnaires. You can ask anything. Still, we are having of the 15 minutes are left. Anyone? You don't have the doubts now? I hope you can do it the fourth sem to get the 80 marks. Systematically, you can read out that one to getting of the good marks. Don't confuse it. There is no confusion at all. I given the clear picture regarding of each and every chapter, which is important, which is not important. If it's important also, sometimes it is some difficulties are there. So that you can avoid it, that one. Because of the within the short span, you can't practice. Whether you have to perfectly practice means you are getting off the good marks in the examination. That's why just to note down the points or prepare yourself as a notes from few chapters, not all the chapters. From the few chapters, you can note down. In the first chapter, D block, electronic configuration of the D block 3D. Next, you can go through the variable oxidation states of the 3D. What is the magnetic property of the 3D? What is the color properties of that one? That's enough for that one. Examination point of view, these are from the 3 essay type question, anyone compulsory. Next, in that only, what is given as, what is double salt? What is coordination number? Double salt. Okay, the definition and given the some examples. In the second chapter, F block elements. What is the classification of F block element? Just lanthanides and actinides. 4A block is called as a lanthanides, 5A block is called as actinides. Simply, cerium to lutetium, thorium to lawrencium. Remember at least these are the 4F means cerium to lutetium, 14 elements. And the 5F means thorium to lawrencium, 14 elements finish. In this question area, why? Because almost all the properties, whatever the D block elements is showing, same properties will be showed by the A block elements also. Why? Because all are metals, all are belongs to the third group elements only. These are inner transition elements. D block is transition element. That's it. The difference is. But here there is a lanthanide contraction is there. Compulsory question. Without this question, there is no question paper at all. What is lanthanide contraction means? A 4F orbital enter into the electrons. It acts as a shield, screen between the nucleus and outermost electron. It acts as a 4F orbital is act as a screen between the center nucleus of the atom and outermost electron. Hence, what happened? The outermost electrons does not attract towards the nucleus. That's why the size is may not be decreases. Means it will be not attracted towards that one. Due to that reason, only they're having of almost all similar sizes. That is called as lanthanide contraction. But not is having of actinide contraction. Actinide contraction is not. It is a fiber. One more black is that means one more RBT will be there. There is no meaning of that one. Next is what are the similarities? What are the differences between the lanthanide actinides? That is a very important question in the second chapter. The second chapter is that is only the important, and the next is the third chapter. We are having of the coordination chemistry. Here again, what is the coordination number? What is the ligand? What is the double salt? What are the we are having of the theories? The theories we are having of that one. That theories we have to learn. Werner's theory. Sidgwick theory, crystal field theory, that you have to learn. Werner's theory, I given the complex compound that is hexaamino cobalt chloride. Werner is explained this one with the help of the complex compound hexaamino cobalt chloride. By that, you are having of 6 coordination number, first molecule, 5 coordination number, second molecule, 4 coordination number, 3 coordination number. Which one is stable? It is explained by the Werner's theory. Next is Sidgwick theory. In that Sidgwick theory, effective atomic number. By means of effective atomic number, you are calculating the effective atomic number. That means that is the next noble gas element. If any complex compound is having of EAN is that is a noble gas element configuration, that molecule complex molecule is very stable. Hexaamino cobalt chloride, it is having of the 36 EAN effective atomic number. That means it is a krypton atomic number. So the compound is a more stable. Whatever the Werner is explained, same thing is explained in terms of different manner by the Sidgwick. Next, crystal field theory, splitting of the orbitals. How the splitting of the electrons will be enter into the different levels. That is splitting will be takes place. That also octahedral structure, square plane, and different manners will be there in that splitting of orbitals. Okay, that is a crystal field theory. Valence bond theory, every time valence bond theory, already you know that one valence bond theory. What is there? How many number of off-field orbitals are present? That much of bonds are formed by the any compound. That is the valence bond theory. When the particular electrons are transferred from one atom to other atom because of the attaining of the stability purpose only. Any atom is losing or any atom is gaining means because of the attaining of the stability purpose. That is given by the valence bond theory. That is enough for that one. Next, in this chapter only, among the 3 essay type question, one more important is isomerism of the complex compounds. That is very, very important. We are having of the 7, 8 points are there isomers. There is linkage isomerism, bridge isomerism, ligand isomerism. These are the importance of given area that you have to learn. That is about the first black. Okay. Next we are in the already I told that the organic part, that is the nitrogen, that is the nitroalkanes, or next is the amines, next is the carbohydrates. That's it. That again I repeated, but no one is asking any questions, doubts. No more doubts, I think so. Right? Anybody? I think no one to ask. Are important questions. These are all are important questions. What I repeated is important questions are these are only from the fourth sem. If you go through the fourth sem previous question paper, you see that one. These questions only there. No more other questions. So try to. This is very important. Is the practice. Only the thing is the practice. First of all, read out the chapters first and make it as possibility. Prepare your own notes. Very important is preparation of the own notes is very important to get the confidence. That is useful on the day of your examination. Just you are preparing means you are writing of your own notes, you are getting of the fixed in the mind. Just once you are saw that at the time of examination, you easily remember that one. You can write easily. And moreover, most of the students is unfortunately they are only you are studying up to the examination point of view, not the knowledge purpose. See, chemistry is a vast syllabus. It's a vast syllabus. Different areas are there, very different areas. But when you saw from the first sem to last sixth sem, a sequence is given. A sequence. If you take the inorganic part, a sequence is given. First A group element, second A, third A, fourth, that is fourth, fifth, sixth, seventh, eighth, D block, F block. Complete periodic table is covered. Complete periodic. Coming to the organic part. First sem we are having of the what is the fundamentals, basic fundamentals of organic chemistry. What is alkanes, cycloalkanes? What is alkenes? What is alkynes? Alkadienes. Next is aromatic hydrocarbons, benzenes. Next, we are having of heterocyclic compounds. Next, we are having of nitrogen compounds, amines, aldehydes, and ketones. In the third sem, fourth sem, like that, it will be expanding slowly the organic part. If prepare your notes by each and every sem, if you collectively taken as organic part at a bunch, you will see a sequence is there. Continuous process will be there. Similar manner, in the inorganic part, we are having in the physical part, atomic structure, gaseous state, solutions. Okay, periodic table is inorganic, of course. Okay, these are the continuous chapter, but there's no link at all in the physical chapters. But it is having of the hydrochemistry part, we are having of the fundamentals are given. Then after slowly it is a increasing of the manner. Suppose if we take the fourth same, we are having of the thermodynamics, electrochemistry, chemical kinetics. Thermodynamics and electrochemistry you can't do in the practicals, but that is chemical kinetics. We can do the one of the practicals. Maybe in the fifth sem or sixth sem, we can do the practicals. Hydrolysis of methyl state or ester hydrolysis. We can prove it is a first order reaction. It is using of the proving of the first order reaction. That is having of the ideas. Okay. So anyhow, the physical chemistry means it is a mathematical background is there actually. Means we can differentiating the everything the orders will be we are having of that one. Even the thermodynamics Carnot cycle is there. The difficulties will be taking of the Carnot cycle in that you are having of the in the fifth sem. That will be there. That you have to learn in this case. Okay, these are all are actually One by one step, it is slowly increasing. You know that up to 2015, it is a year-wise syllabus is there. From 2015 onwards, SEM is introduced so that that syllabus only, 3 years syllabus only divided into 6 parts. That's it, nothing more. But you are having of electives are there. In that electives, new topics are introduced. We are having of the polymer chemistry is there. We are having the green chemistry is there. Drug chemistry is there, and also so many others. That is the electives are present. That you are getting of the more knowledge regarding of this chemistry. Why? Because so many number of branches are there. In the branches, some of the important topics we are selectively taken into particularly electives. Elective A and B in the sixth sem we are having of fifth sem we are having of so many electives. Here also one more elective we will be getting of. So like that we are having of this particularly. We can go through that one. You are getting of some idea. First of all, basic fundamentals you have to learn. Then only you will go to that one. Okay. Otherwise, because of if you go to the sixth sem, in that totally spectroscopy is there. What is NMR spectra? What is mass spectra? That you have to schematic diagrams will be there. How the peaks are obtaining, where the peak is obtained, whether it is a functional group of OH or aldehyde or acid. Which functional group of peak is there? By means of seeing of the peak only, you can identify the functional group. There is a spectroscopic studies are there. When you are getting off that particular idea means, then the basic fundamentals, if you are learned properly, then only you are getting off that idea. Otherwise, a very little vast, that means you can't confuse it totally. Why you are studying like this? You don't know. Why? Because these fundamentals, if you are having of the knowledge, then only you can go to that one. The concept is. If stereochemistry is there, already I told that in the chapter you are having the N-butane enantiomers. What are the enantiomers? Are the N-butane. You are having of eclipse guard, cis, anti, Gachi formula. These are the why their formula means they are due to of the spin of the rotation of the particular N-butane. You are getting of the different structures. In the structures, you are having of the 4 formulas are there N-butane. Sometimes 6 is the in that which is the stable one. Most stable is which one? Anti or Gachi. Or they are having a cis form or anti form. That you have to identify with the help of the rotation of the particularly methyl substitution. Means CH3 is there. Sometimes H hydrogen will be spinning of that one. Due to of the rotation of 180 degrees, it will be making of like structures. So this is the enantiomers will be taking space. Like that.
Sir,
Um,
yeah, our physics classes are not conducted. So, is there any possibility that you can ask help from the physics teachers and give us the important questions and all?
sorry, I can't understand your question.
Our physics classes are not being conducted, sir, for this past 6 days.
Physics
So, is
part.
there any possibility that you can ask help from the physics teachers and tell us the important questions?
Totally physics is not conducted any class.
Yes, sir. No class has been conducted.
Why it is on the schedule? It is there, na?
Actually, sir, after your class, we have maths and physics together.
Okay.
Maths is
You are
being
attending the
conducted, but
maths class.
not
You are attending the maths class. Simultaneously, physics class is going on.
yeah. But
Okay.
the
Due to
physics
that,
class is not.
we are missing that class. Okay. Anyhow, you are. This is whatever the Zoom meeting is recording. Afterwards, also you can take the YouTube. Na? You can listen that particular classes. Na? Physics class. Why? Because one thing
No, sir. Teacher is only not attending the class.
you're not taking anybody.
No, sir. No one's taking the class.
Okay. At least you have to complain to the student director, na. They will arrange the one more lecture. Otherwise,
Sir, they won't respond. Like before this, also it has been the same problem has been occurred, but we were not informed about this, sir.
okay. Fine. Okay. Anyhow, my number is there, na. You are having my number. Okay, and that I will put some questions on this. And suppose I think about that one, if possible, I will take off that particular physics topics. If any, some important, not all the syllabus point of view, some important lessons. I'll give that one in that. Okay, so don't worry about that physics also. Just practice. The main important here is you are the MPC student means you have to practice. Put on the paper compulsory, practice it. Most of the students are chemistry students are just reading the book. Reading is not the good, that is practice. It is not a good practice reading. Reading, getting of the some knowledge, but you can't write in the properly. What are the steps involved? Just you have to practice, put on the paper means you are getting of some confidence. So step by step you are having of that one.